Hello everyone, my name is Nithan, and in this video I will be demonstrating my project titled Real-Time Protocol Upgrade Monitoring System, which I have built completely using the C++ programming language. The objective of this system is to track blockchain event in real time, specifically from Ethereum and Polygon networks, evaluate upgrade proposals, simulate marketing sentiment, and generate strategic insight for the traders or analysts. As the program starts, you will see prints section title left panel, right panel, and center panel. Left panel, this is left panel. The left panel is network monitoring, which displays the most recent block number that's live from both Ethereum and Polygon blockchains using the Etherscan API. This block monitoring is done in real time through multi-threaded execution, allowing the system to query both chains simultaneously without blocking another operation. Next, we have central panel. This is an upgrade risk assessment which I simulate a governance proposal titled Reduce Swap Fee and calculate its risk score based on votes in favor versus total votes. The risk score is printed between 0 to 100. For example, 68 by 100, like 68 by 100, it can be to reflect how risky is conversational a protocol upgrade is based on the community consequences. In this right panel, sentiment and strategies, the system runs several prediction models such as sentiment analysis, liquidity forecasting, volatility risk, machine learning based governance, outcome prediction, and finally a portfolio strategy recommendation. Each of these modules runs in a separate thread, prints its output to the console that helps simulate what kind of market action might be expected before or after protocol upgrade. The sentiment model currently returns random outcomes such as negative, neutral, or positive, along with the corresponding recommendation like monitor, hedge risk, or act first. Finally, the system displays portfolio suggestions and rebalancing tips such as reduce export or volatile assets to help users make risk-aware decision in the DeFi environment. So now we can view code review and explain the architecture. Now let's look the code structure in the system. Behind the system, is using before I say standard C++ and follows the modular design pattern, which proposes of the separation on logic into header source in under the include directory here and source directory under uh, directories respectively. Include is an header. Here source files are there. The main.cpp, the main.cpp is the entry point of application. It loads configuration from the console.json. While it launches eight threads, each handling specific task, blockchain monitoring, governance, evaluation, sentiment check, or ML-based suggestions. The monitor C++, the monitor CPP is the handles network monitoring. It used to lib curl to fetch the latest block number to Etherscan API prints them respective chain label and the governance.cpp. Here, the governance.cpp includes a logic calculate the basic upgrade risk score based on how many votes are in favor of a cost proposal versus the total votes cost. The sentiment.cpp is a simulate real-time market sentiment by randomly selecting one of three possible outcomes in the production setup. This would be replaced with a proper NLP engine, parsing filter, or community posts. The volatility CPP, this file and liquidity CPP like this one. uh, it's like forecasting TVL movement respectively through the currently written placeholder message and ML predictor CPP that mimics the machine learning models predicting the success rate of the governance proposals and suggests changes users define portfolio actions. The entire system built using the make that compiles all C++ source files and links required to libraries such as libcurl, libjson, cpp, and pthread for the multi-threading configuration like etherscan. Here I will do configuration etherscan API and upgrade topic risk threshold value stored in the externally data inside console config.json to keep the code flexible and not independent. The architecture is ensure real-time responsiveness by running each module in parallel thread, which is ideal for high-speed financial and blockchain application. The model performance is like now let's talk about model approach, how the performance is accuracy and in this C++ version. In case sentiment analysis of current version randomly assign the market mode, but the system structure in the way of is services based on Python NLP like services or BRT based model can be integrated in future to give real sentiment for Twitter or example Reddit, but here Twitter. The machine learning part is predicts proposals outcome currently uses fixed text outputs, but this can replace it with a logistic regression and decision tree model and training for the real voting data from platform like Snapchat or Tally. Although the project is fully developed in C++ and this is a make file, and also for the performance standards because of the system users multi-threading each components runs independently without slowing down the others, ensuring the smooth and scalable architecture. Further optimization could include API caching and rate limit handling and even deployment these system into graphical interface using the library like QTR IM GUI. This is to summarize the project demonstration like how real-time protocol monitoring system beneficially built efficiently using C++ and focus on modular architecture, multi-threading, and extensibility for advanced analytics. Through many of the modules, placeholder now framework designed with performance flexibility and real-world use cases mind. Thank you so much for watching my video, and this was my demonstration of real time protocol upgrade monitoring system.